Good morning, mathematicians. We are thinking about week 19, the Monday column. Let's begin with some multiplication. Boys and girls, we are thinking first about 6 as our first diva, the center of this multiplication universe. 6 times 8 is 48. Here's my 8, carry my 4. 6 times 5 is 30 plus 4 is 34. Here's my 4, carry my 3. 6 times 3 is 18, 19, 20, 21. This is my first partial product. Now remember, boys and girls, we are going to cross off the 6. We're going to cross off everything that was carried. My 4 is starting in the tens place, so my answer must start in the tens place. That is why, dun, 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 magic 0. Now let's move on to our 4 times 8 is 32. Here's my 2, carry a 3. 4 times 5 is 20, plus 3 is 23. Here's my 3, carry my 2. 4 times 3 is 12, plus 2 is 14. I must keep my work nice and aligned. Certainly in these small boxes, that can be tough, but we can do it. My answer here, 1, 2, 3, comma, is 16,468. I'm excited about the opportunity to talk about this problem because this gives us the chance to think about what to do when we have 3 diva digits. Let's start with the 1 as our diva. We know that anything, including 2,843 times 1, is going to equal itself. So we could simply rewrite that, or you could walk through it. 1 times 3 is 3, 1 times 4 is 4, 1 times 8 is 8, and 1 times 2 is 2. We're going to cross off our 1. That is the first diva digit. We're going to move on to the 4. My answer must start here, so I need 1 golden 0. Now we're moving on to 4 times 3 is 12. Here is my 2, carrying 1. 4 times 4 is 16, plus 1 is 17. Carry that 1. 4 times 8, or excuse me, yes, 4 times 8 is 24, plus 1 is 25. Here is my 5, carry my 2. 4 times 2 is 8, plus 2 is 10. And now I'm going to move on to yet another diva. Now this 3 is in the 100 place, so my answer must start in the hundreds place. I have crossed off 2 other divas. That is why this one actually requires 2 golden zeros because my answer is starting in the 100 place, 300. So my answer must start in the 100 place as well. It's really not magic. It's really just math, but that's okay. We can still call it magic. That makes it more fun. Here we go. 3 times 3 is 9. 3 times 4 is 12. Here is my 2. Carry my 1. I really should cross off everything else that has already been carried so I don't get confused. This is the one, boys and girls, from this fact of 3 times 4 is 12. Here is my 2, carry my 1. 3 times 8 is 24, plus 1 is 25. Here is my 5, carry my 2. 3 times 2 is 6, plus 2 is 8. So now I have 3 partial products to add. 3 plus 0 is 3. 4 plus 2 is 6. Here I have 16 plus I'm going to add 8 more. So I'm looking at 24. Here is my 4. Carry that 2. Now I have 2 plus 2 plus 5 plus 2. 2, 4, 6. I've got 11. This is a 1. Carry the 1. This I'm looking at 6. And this I'm looking at 9. So boys and girls, I have quite a large answer. 1, 2, 3, comma. The answer to this question is 961,463. That was a tough one, but I love thinking about the extra magic zeros. Let's go ahead to our next question. This one is kind of silly. It says, night, night, the sleepy night is putting his nights into groups of 15. He has 330 nights. How many groups can he make? Boys and girls, the strategy you choose is yours for the choosing, but I'm going to go ahead and use the area method. Many of us have been liking that in math class. I know that I could get at least 20 groups of 15 from 330. 2 times 15 would give me 30. And this 0 I would bring down. See how I can use that easy peasy fact of 2 times 15 equals 30, and then add that extra zero to be able to do these facts mentally. I'm going to subtract, and I see that I have exactly 30 left. That 30 is going to be brought into my next column. And now I would ask myself, how many groups of 15 could I get from 30? Of course, we know that's exactly 2. That would use up 30, and we would have none left. All right, boys and girls, I'm going to switch to a different pen since that one is not working so well. I know that my answer can be seen right here. There are exactly 22 groups that he can create. I am asked to explain my reasoning. One thing I could say is that for the beginning of my problem, I did 300 divided by 15. Then my next part, I did 30 divided by 15. We know that that equaled, this was our 20, this was our 2, and that gave us the total of 22. That's one way that I can show my reasoning with an equation. All right, boys and girls, let's take a look at our next problem. I did go ahead and write it out up top here so that I had a little bit of room to work. It says to explain why this equals this. To start, let's go ahead and let's just look and see how that works and why that works. I am breaking up 483 and 480 and 2, 482. When I break that into when I break that into 482, now I can divide each of those parts by 2 to make this problem that I can do with the distributive property. 200 divided by 2, or excuse me, 400 divided by 2 gives me 200. 80 divided by 2 gives me 40. And 20 divided by 2 gives me 1. So in all, this gives me 241. That is the answer to this problem that I'm going to write down below. It did ask me to explain why this works. I wanted to show you what the thinking was to make that a little easier to understand. But certainly we can write, we are breaking up 482 into its individual units and dividing them. That is why it works, boys and girls. Okay, we have 2 problems left in this Monday column. Let's go ahead and look at this. It says solve the following using partial products and area model methods. We have 523. So I have labeled each part of my box with the individual unit. Again, I have 524 actually, and I'm so glad I just took a look at that because this should not be a 4. This should be a 3 because I have 523. Now we are ready to work. Remember, boys and girls, we can use our basic fact with zero trick. 4 times 5 is 20. Now that 0 was part of the basic fact. I do need to put 2 extra zeros to the side because those zeros were the basic fact. With zero trick, you carry down the extra zero. Now I'm going to do 4 times 2, and that's going to give me 8. Then we ask ourselves how many zeros exist outside the basic fact. There's 1, so that is 80. Lastly, we just have 4 times 3, and that is 12. Boys and girls, when I look at this problem, what we just did is we took our 4, that was our number over here, and we multiplied it by 500 here, 40, or excuse me, 20 here, and 3 here. When we did that, we found that 4 times 500 gave us an answer of 2,000. When we did 4 times 50 or 500, we got an answer. I think the girls and Selena is trying to do too many things at the same time. Let me wipe this out. I apologize. Let's take a look at this. We already did our 4 times 500 here. Here we're going to do our 4 times 20. That looks better. That gave us our answer of 80 in the middle box. Lastly, we had our 4 times 3, and 4 times 3 gave us our answer of 12. Now, when I join that together, my 2,000, my 80, my 12, I get a final answer of 2,092. Okay, guys, that was our partial product and area model method problem. Our last problem for Monday is thinking about multiplying fractions. I went ahead and wrote it out to the side to give ourselves a little bit of room to work, but I do want you to remember what we've talked about. We can simply multiply our numerators, multiply our denominators, and get our answers. So 4 times 2 is 8. 5 times 3 is 15. This is 8/15. 7 times 5 is 35. 8 times 6 is 48. My answer is 35/48. Here I have 3 times 1 is 3. 4 times 2 is 8. My answer is 38. Boys and girls, in 5th grade, we don't have to simplify our answers. So you may leave them exactly like that without thinking about if there are any lower terms that we could express that with. Boys and girls, that is it for week 19